Okay, remember there are 4 different ways that we represent things in math. One is with an equation, one is with a graph, one is with a table, and one is with words. So here we have a problem with a table. We're given a table of functions. This is your x value 2. This is the y value from f, evaluated at 2. This is the derivative at 2, right? The slope of your tangent line. This is g, some other function evaluated at 2. And this is the slope of the g tangent line at 2. And our function says this is your function. H is f of x over g of x. So what is h prime at 2? What is the slope of the tangent line to the function h when x equals 2? Okay, so what rule are we going to use to derive this? The quotient rule, right? This is a fraction. It is a division problem. So we're going to use the quotient rule, which says, right, h prime equals the low function times the derivative of the high function. So f is the high function, so it's f prime, minus the high function f times the derivative of the low function g, divided by the low function g squared. Okay? So that's the derivative. We are done with the calculus part, right? The derivative is the calculus. So now we want to evaluate it at h of 2, which means we're going to find the g value at 2, f prime at 2, minus f of 2 times g prime at 2, all divided by g of 2 squared. Okay? So this is what we're doing. We want to evaluate our derivative at a single point, at an x value. So all of these guys are going to come from my table up above. Okay, every one of these values is given to us in the table up above. Okay, so let's see what those are. What is g of 2? Negative 2. So that goes there. Times, this is times right here, f prime at 2, which is negative 3. Okay, and then minus, right? We're not going to change the sign, but minus. F of 2 is 4 times g prime of 2 is 5 over g of 2 once again is negative 2, and we're going to square that. Okay, so all of our answers, all of our numbers come from our table. So now let's do it step by step, piece by piece, and see what we get. Negative 2 times negative 3 is positive 6. Minus 4 times 5 is 20, divided by negative 2 squared is positive 4. Okay, so 6 minus 20, that's negative 14 divided by 4 simplifies to, we can divide both of these by 2 and get negative 7 over 2. Or if you want, negative 3.5. All right, number 2, right? This is our special form of the definition of a derivative. So this is asking us to take the derivative of what function? Secant. This is just the derivative of secant, right? All this fancy stuff is just asking us to take the derivative of secant. Okay? You need to recognize this form as the definition of the derivative. Okay, you're not going to have to do any algebra with this, which we normally do, but now that we know all the rules, we can just do the rules. So if you haven't memorized the secant derivative, secant is 1 over the cosine, and you can take the derivative by doing the quotient rule. But if you have memorized it, then it's pretty easy. The derivative of secant is secant x times the tangent of x. Right? Whatever you have in your argument. And if this were something more than just x, our last thing would be to multiply by the derivative of your parentheses, right? That's the chain rule. If you have something in parentheses other than just a single variable, then make sure at the end you multiply by the derivative of that parenthetical equation. Okay? But here we don't have it, so our answer is just secant x tan x. Number 3, this is another one of those things you need to recognize. Okay? Because we're not going to do any quote-unquote math here. You need to recognize this as being, we need to take the derivative of this function, take the derivative here, and evaluate it at the point pi over 6. Okay? So if this is our function f, then we are taking the derivative of f, and we are evaluating it at pi over 6. That's what this whole entire question is asking us to do. So first, let's take the derivative of cosine squared. Okay? Cosine squared. So remember, we can rewrite this as the cosine of x raised to the second power. We can take this 2 here and we can put it outside so that we remember this is a chain rule derivative starting with the power. Okay? So there's a power function and there's a trig function. So first we're going to take the derivative of our power, which means we take the power and bring it to the front. So our first derivative is 2 times the cosine of x to the first power, right? Because it's always minus 1. But of course, we don't ever write to the first power. That would be ridiculous. Everything is raised to the first power. And once we've done that, now that we've done the power derivative, we can come back and take the derivative of cosine. And the derivative of cosine is negative sine. And then once again, if there were something in parentheses, we would multiply that by the derivative of the thing in parentheses, if it's more than just x. Because the derivative of x is just 1, and multiplying by 1 doesn't change anything. Right? But since there's nothing in parentheses there, we don't have to worry about that part. Okay, so then a final simplification would be negative 2. Remember, this is a multiplier of negative 1, not a subtraction problem. So negative 2 cosine of x times the sine of x. And we're trying to evaluate this at pi over 6. Okay, so now that we've taken the derivative, we can plug in our x value that we're trying to use. Okay, so it's evaluated at pi over 6. So let's evaluate it. So now let's go to our unit circle. So let's see what we remember about our unit circle. The cosine at pi over 6 is root 3 over 2. Positive root 3 over 2. And the sine at pi over 6 is 1/2. Okay, those come from your unit circle. The cosine is the x-coordinate of your point, and the sine is the y-coordinate of our point. So when I multiply this all together, right, I can do some simplifying. I know that 2 divided by 2 is 1. So I multiply all of my numerator stuff together, and that just gives me root 3, because root 3 times 1 is root 3. And then I just have a 2 on the bottom, so my final answer is negative, right, because I still have my negative out front, negative root 3 over 2. That is my final answer. Here is your function now for number 4, cosine squared of 2t. What is the first value t from your unit circle such that the derivative equals 0? Okay, so the first thing we have to do is take the derivative, s prime at t. So once again, this has a 2 here, right? It has a 2. So that's going to be our first step in this chain rule derivative. The 2 comes to the front as a 2, and then we have cosine of 2t to the first power. So we don't ever have to write to the first power, just know that it's being raised to the first power. Now, we take the derivative of cosine. The derivative of cosine is negative sine, also of 2t. Our parenthesis hasn't changed yet. We've just taken the derivative of cosine. And now our last thing to do is take the derivative of 2t. And the derivative of 2t is 2, multiplier of 2. So let's do some simplifying. I have a positive 2 times negative 1 times positive 2 is negative 4. Cosine of 2t times the sine of 2t. So that's my derivative. Okay, that's my derivative of cosine squared of 2t. And I want to know what value of t makes that equal to 0. Right, that's what the problem is asking. What value of t makes this 0? Okay, let's solve this. So notice we have this negative 4 multiplier, so why don't we just divide both sides by negative 4? Right, that will get rid of that thing right there. So that leaves us with the cosine of 2t times the sine of 2t equals 0. Okay, so we're going to apply an algebraic property to this product, right? This is a multiplier. If I have two things that multiply to give me 0, that means either this has to be 0 or my other part has to be 0. Okay, the sine of 2t. One of these two values has to be 0 in order for their product to be 0, right? We do this in algebra all the time. We factor a quadratic, you set the factors equal to 0. Okay, so we're doing the same math idea here with our trigonometry. Okay, we want to move the cosine to this side. And we always move a cosine by taking its inverse. You probably haven't done this in a while, so we're going to take the inverse cosine of both sides. Okay, so you move the cosine over, because our 2t is in parentheses. You can't divide by 2. No, you don't ever do that out of parentheses. So we move our cosine. Okay, now this is asking us at what angle is the cosine equal to 0? So from our unit circle, that happens at pi over 2, and that also happens at 3 pi over 2. Right? That's 90 degrees and 100 and 270 degrees. Those are the two places on your unit circle where the cosine is 0. Okay, so now our last step is dividing both sides by 2, aka multiplying by 1/2. So I have a final answer of pi over 4 or 3 pi over 4. Okay, now pi over 4, it comes before 3 pi over 4, so I know at least my answer is going to be pi over 4, right? But I'm not done yet, because maybe sine gives me a sooner, right, an earlier answer. I want to know what is the first time that it hits. So we're going to solve this guy. Same thing, we're going to take the inverse sine of 0. That's how we move a trig to the other side, is by taking its inverse. Okay, so what are the angles on our unit circle where sine is 0? At 2 pi and at pi. But it says up here, right, 2 pi is not included in our answer. So the only place is going to be pi. Okay, so dividing both sides by 2, t equals pi over 2. Now, which of these two answers, pi over 2 or pi over 4, come first on your unit circle? The answer is pi over 4. It has a larger denominator, which means it's a smaller angle. Okay, here we have your values represented by a graph, right? We have two things to think about. We have the y values of the graph, and we have the slope of the graph. But here is our function. 2x times f of g of x. And we want to find h prime at 7, okay, which means we need to take the derivative. So what rule are we going to use to take the derivative of this function? This is the product rule, okay? That's the product rule because I am multiplying two things. I have a 2x function and I have an f of g of x function, right? These are two things being multiplied together, so this is a product rule derivative, right? So we can do a times b prime plus a prime b, or you can switch them and do a prime b plus ab prime, right? The order in which you do this does not matter. So I'm going to do it in the ab prime plus a prime b order, which means I need to find my 2x. So here we go. H prime is equal to 2x, doesn't change, right? That's our first function. But what's the derivative of our blue thing? What do we need to do to take the derivative of this? This is a chain rule. So we're going to use the chain rule to take the derivative of our second function, which looks like f prime times g prime. Right, first we take the derivative of the outer function, which is f. So there's our f function, and we leave the inner function alone, right? Nothing has changed on the inside, and then we multiply it by the derivative of the inside. Okay, plus. Now let's go back and take the derivative of 2x, which is just 2, and we're multiplying that by f of g of x. So there's the calculus. We have taken the derivative correctly using the product rule. Okay? But within that, one of our functions, we had to take the derivative using the chain rule. But this is a product rule derivative. So now let's replace x with 7. So everywhere I see an x, I'm going to put a 7. Okay, now let's evaluate as much as we can. Well, 2 times 7, that's 14. F prime of. Okay, to get this one, I need to go to my g function and figure out what my y value is. So when x is 7 over here, what is my y value? 0. So I'm going to plug in 0 right here. Okay. For my next part, for g prime, I'm going to look at the slope. What is the slope of the line as x crosses 7? This line has a slope of positive 2. 2 up, 1 over. Right? Slope is the derivative. Derivative means slope. So this, at g of 7, the slope is positive 2. Okay? So we have a y value versus a slope. And then, of course, g of 7 was 0, so we're going to put a 0 back in there. Okay, let's keep going. Our next thing to do is to evaluate f of 0. F prime. So what's the derivative? What's the slope of our line at 0 from our f value? So we'll come over here to f. We'll find out when x is 0, and our slope is negative 1. 1 down, 1 to the right. So if our line is going down, that means we have a negative slope. So this is negative 1. And I'm still multiplying that by 2, right? Because this 2 stays here. We haven't done anything with that yet. Plus 2 times, what is the y value from our f graph, right? This is a y value. F of 0 is the y value. The y value is 5. So we're going to come back in here and we're going to put a 5. Okay, so now I have everything I need to evaluate my numbers. Negative 1 times 2, that's negative 2. Negative 2 times 14 is negative 28. Negative 28 plus 10 is negative 18. So my final answer is negative 18. Okay, number 6. This is just an exponential derivative. So you need to memorize how to take the derivative of an exponential. So the fun part is the derivative of an exponential is itself. Right? Whatever we see here, the first part of the derivative is that exact same thing. Now we multiply that by the derivative of your power. And the derivative of 3x squared is 6x. Okay, so we could simplify this a little bit by bringing the 6x in front. So 6x times e raised to the 3x squared power. Nothing changes with our powers. That's the derivative of e to the 3x. Okay, our last one here. We have the natural log of a, there's 2 more. Natural log of a square root, find the equation of the tangent line when x equals 4. Okay, so we need to know 2 things. What is our y value? Okay, our y value comes from evaluating our function. So the natural log of the square root of 2 times 4, right? The x value that we're told at is what happens when x equals 4. Okay, so our first part is just plugging our value into your given equation. So if we want to know what the y value is, and we need the y value to write the equation of our line, we just plug it right in there. So this becomes the natural log of the square root of 8 minus 4, which is 4. Then the square root of 4 is 2. So our y value for our equation is the natural log of 2. That's our y value. Okay, and the second thing we need to know is the slope. And to find the slope, we have to take the derivative evaluated at 4. Okay, the slope comes from the derivative. So this is, once again, going to be a natural log derivative. So hopefully you've memorized your natural log derivatives. So 1 over the square root of 2x minus 4 times the derivative of the square root of 2x minus 4. Hopefully you've memorized this one also. That's 1 over 2 times 2x minus 4 times 2, because we have to do the chain rule and find the derivative of your inside last. Okay, this one has a triple part derivative. First we do natural log, then we do the square root, then we do the times 2. Okay, but don't worry, it becomes pretty simple. 2 on top, 2 on bottom, and if we have a square root times itself, that means the square root goes away. So our derivative is basically 1 over 2x minus 4. That's the equation for your derivative. Now when I plug in 4, I get 1 over 4, because that's 8 minus 4. So my slope is 1/4. That is my slope that I need to write the equation of my tangent line. Okay, which looks like this. Y minus the y value, natural log of 2, equals our slope, 1/4, times x minus the x value that we were given was 4. So that's the equation of our tangent line when x equals 4. Okay, let's look at our last problem. Remember now, this is telling us to take the derivative of this function and evaluate it at this point. Okay, so we're going to start with the derivative of sine squared of half of x. So we start with the power. We bring the power to the front. So 2 times the sine of half of x. And then we multiply that by the derivative of sine, which is cosine, right? And it's still cosine of half of x. We haven't messed with that yet. Now our last thing to do is take the derivative of half of x. And that's going to be 1/2, right? Because x over 2 is the derivative of x is 1, so 1 over 2. Okay, so when we put this all together, we have 2 times 1/2. Well, that's just 1. So it's the sine of half of x times the cosine of half of x. Now I'm going to plug in my pi over 3. Okay, so I'm going to rewrite this a little bit so it makes more sense. So half of pi over 3. Okay, so half of x. Half of pi over 3. Okay, so hopefully you know that half of pi over 3 is pi over 6. The cosine of pi over 6. Now we go to our unit circle. The sine at pi over 6 is 1/2. And the cosine at pi over 6 is root 3 over 2. Both of them are positive. So when I multiply these two things together, I get a final answer of root 3 over 4. Okay, there we go. There's all of your review for your derivative rules test. Do great.